All right, so we're back to this reduction formula problem. So sorry about the interruption, running out of time on that video. At least it gave me time to eat that cupcake. So here's where we're at. Okay, we mentioned that if we distribute this, okay, we're going to have a sine to the n minus 2 minus a sine to the n. So let me write that down here. So we've got the integral of the sine to the nth power All right, so here we go. We have a sine, I'm going to write it this way now, to the n minus 2 minus sine to the nth, like that. Just a lot of repeat writing here. Now, when I get to this spot, what I'm going to do is I'm going to split this up into the two different integrals because I have that subtraction. I'm going to take the integral sine to the n minus 2 minus, now remember I have to distribute this n minus 1 to everything, so n minus 1 times the integral sine to the n. And in that last video, I got pretty excited right before the end because we had a sine to the n, which matches the sine to the n here. So we're at a spot where we can combine like terms by adding this over. So we're going to add n minus 1 sine to the n to both sides. So how many of these integrals do we end up with here? We had one of them, and we're adding n minus 1 of them. Or another way to think about it, we have n minus 1 of them, and we're adding one more of them. How many do we have? We have n. And that's where we're at. So now we're solving for the integral of sine to the n. Okay, for this reduction formula, all we have to do now is divide everything by n. Okay. This gives us this reduction formula. And where's that? Negative 1 over n cosine sine plus n minus 1 over n integral sine to the n minus 2. Okay, let me just double check I wrote that down right. Okay, there you go, looks good. So why do they call this a reduction formula? Well, remember, we're starting with sine to some n power. According to this formula, we can work that integral down to the sine with an exponent that's 2 fewer than what we started with. We're reducing the exponent from n down to n minus 2. Okay, that's why it's called a reduction formula. Is that helpful? Well, you're still going to end up with an integral here. But maybe that integral has reduced it down to a nice power where you can just find that integral. Or maybe you have to use a reduction formula more than once and keep reducing that power down. So just to clarify, if this was a third power, using this reduction formula, we would have it down to the integral to the sine to the first power. 3 gets reduced by 2 down to 1. And if this is a sine of the first, we could find that antiderivative. Now, there are lots of reduction formulas that we can make. We just made one for sine to the nth. You can think about cosine. There are other functions as well. You're going to be exploring some of that in your practice. But let's just put this into application here. how does our reduction formula help us find the integral of the sine squared of x dx? We don't have to go through all that work of integration by parts again, especially if we have to do it multiple times. On this one, our n equals 2. So if we use our formula, the integral of the sine squared of x dx equals negative 1 over n, negative 1 over 2, cosine of x, sine of x, plus n minus 1 over n. N is 2, so this is 2 minus 1 over 2, which is just 1 over 2. Integral sine to the n minus 2. So that's going to be sine to the, our n was 2. It reduces it down to 0. Now if it reduces that down to 0, anything to the 0 power is 1. So this is equal to negative 1/2 cosine of x, sine of x, plus 1/2. What is the antiderivative of 1 dx? X. And we have our plus c. I don't think I put my plus c on this one. Okay. Make sure that you add your reduction formula to your derivative and integral sheet. I will allow those to be on there. I want you to compare. We did do a cosine squared before. Okay. And, well, I guess that was a definite integral, so we ended up not seeing exactly. But it would look pretty similar to what we did. Sine of the fourth. What are we going to have to do on that one? I'll save the video on this. You're going to have to take it from a fourth down to a second using the reduction formula one time, then use the reduction formula again to take it down to the 0th power. Sound good? All right. Sorry about the length of these two combined videos, but you should be all set to go.